Intelligent textiles are an exciting new technology with potential uses in areas as diverse as healthcare and emergency management. But most of the textiles currently on the market require wires, straps, or miniature electronics to work effectively. Not so with this fabric. By using chemistry, nanotechnology, and textile structure, one company has created a product where the fabric is the technology.
The fabric is the technology because it's actually incorporated within the knitted structure of the garment or the base layer fabric that's being used. So the fabric being the sensor means that it's an electrically conductive yarn and Footfalls' proprietary structural technology. This technology is different from what's already available because there are no wires or solid-state electronics in it. It is knitted within the structure of the fabric. It is an electrically conductive yarn, Footfalls' proprietary technology, and it means that it is able to drape and form and feel like any knitted fabric that you are able to buy today.
Kiwi startup Footfalls and Heartbeats is taking this technology to the world. They're working with one of the world's leading smart textile research groups at North Carolina State University to turn the fabric into products. This compression bandage is one of the first. It solves an age-old problem with healing venous and diabetic foot ulcers, that of providing the correct level of tension to enable healing without damaging the skin.
In a compression bandage, the textile works by measuring the compressive force that's being applied by the practitioner. So within the sensor area, the textile produces a drop in resistance, which is converted via an algorithm to a measurement which is readable by the technician or the practitioner who's applying the compression bandage. On the computer here you can see a figure of resistance, and the resistance drops as the bandage is being applied over the top of the Footfalls technology. So tightness or compressive force is shown on an interface in millimeters of mercury, which is the standard clinical measurement which is required by practitioners when they apply compressive bandages.
We've never been able to before in real life able to measure the level of pressure that we are applying to the patient. Lots of patients are quite nervous about having compression therapy applied to their lower limbs, so it would give them the confidence to know that the pressure that we'd applied was not going to cause them any harm. So yes, it just gives us the confidence to be able to know that we are providing our patient with the best possible care and treatment. The whole concept is revolutionary. I work as a wound nurse specialist and I can see lots of other applications and uses for this product.
The global medical compression market is a $2 billion plus market, and that's just for the compression bandages. There's a similar size market also for compression hosiery post-therapy. The textile has multiple applications, medical compression, but also sports compression, other areas of healthcare. We can measure temperature, pressure, stress, so that creates opportunities in respiratory health, post-cardiac events. The medical officer for a global corporation describes our technology as truly disruptive, and that is encouraging for us and speaks to the scope of potential applications. Also in composite technologies, so including our textile as part of the composite structure, we see opportunity to monitor the real-time stresses on complex structures like high-performance sports cars, yacht spas, and also satellites. Footfalls and Heartbeats has an opportunity to focus on licensing its technology to corporates, and we intend to work with those corporates to customise our technology to their particular application and then to secure ongoing royalties from the sale of their products. We're looking at up to 20 licenses with specific corporates in different applications.
Footfalls and Heartbeats, the company that has developed a revolutionary and proprietary process for manufacturing smart textiles where the textile itself is the sensor.